Welcome to today's panel discussion, MES and the role of AI. MES systems are evolving to provide a new level of sophistication to support designers and manufacturers. This panel will discuss the expanding use of digital twin systems, the value proposition for each step of your Industry 4.0 journey, and how to motivate workers and operators to buy into the process. I'm delighted to be joined by Michael Ford from Aegis Corporation. Next to him, we have Francisco Alamada from Critical Manufacturing. Next to him, we have Geddy Make from Arch Systems. And to my immediate left, we have Ryan Gamble from IntraRatio. So welcome, gentlemen. Thank you for joining me. So let's get started. My very first question, what is the primary purpose of a manufacturing execution system in electronics manufacturing, and how does it help to improve the operational efficiency? An easy one to start, so let's start with you, Ryan.
Perfect. Yeah, just for operational visibility and control, really, at the end of the day, for us, the way we look at it, it's really just to give you a point of which to see what's happening within your factory, how to optimize, have the data, the information in real time to, and ultimately to serve just the higher orders of reliability requirements on products today. Our dependency on everything that's electronics is just growing and growing, and so just solving that challenge.
And you know, does it also have a function to help do some of the heavy lifting, some of the heavy data crunching coming off of the line software in the factory? But I'll let you answer that, Geddy.
Yeah. From line stopping, you're saying?
No, I'm saying, does the MES system have a function to do some of the heavy data crunching coming off of the line software?
Yeah, I believe that some of them it is.
Mhm.
I mean, it's harmonizing several data that are critical for following up, the production and what is the status. Not just, the product itself, but material and, harmonize it with the entire. So I will, yes, call it like heavy. From that
Okay.
point of view.
So, Francisco, do you have any further views on what the function of an MES system is?
Of course, absolutely. Yeah, I think the way I see the functions of an MES is a mapping of processes. So we map on a digital format, business processes and physical processes.
Yes.
And then through that, get the right levels of visibility, the right levels of control. And from there, derive efficiency, improve quality, improve the launch of new products, new processes. So it's a fundamental aspect, let me say, of the Industry 4.0 revolution in that sense.
Right. Okay. Surely you're not going to add to that, Michael, are you?
I'm ready. I think MES has evolved in terms of what it used to be and what it represents today. Because in the past, we used to have just ERP that would try to manage our factory, but nobody was there to make sure that things happened properly. And so MES was created to really make sure that step by step everybody knew what they were doing and make sure they did it properly. Today, because MES is now doing all of that and monitoring, taking data from all of the different processes. Okay, we started to have dashboards, reports, having visibility of the operation, but that's now evolved further to create decision making. So we introduced hardware automation to do things automatically for us instead of using our hands. Software in MES is now smart, so that instead of having to think about every tiny little detail, we can have that intelligence brought to us. And then we can start to make decisions about how to improve things, as you said, with the quality side, performance, productivity, OEE, all of those different things. So as MES goes forward, we're going to see more smartness, if you like, coming in and automating our factories for us.
Absolutely. Okay. So let's, that's a fairly comprehensive explanation of MES. So if you don't understand what it is by now, then there's a problem. Okay, how does the concept of a digital twin apply to electronics manufacturing, and what benefits does it offer in terms of product development and quality control? Let's sort of index it up a bit, and then we'll start with you, Geddy, this time.
Yeah. So digital twin actually provide I would say from several aspects. First of all, from the engineering point of view, having a tool that they can design and optimize for the right process in a way that it doesn't disrupt the operation, first of all. And secondly, visualization. Michael was talking about visualization, of what is happening. Digital twin will be one of the options to visualize what is happening correct, in the actual line to see in a digital way, from my point of view.
Okay. Let's go to Ryan. We'll go to you next.
Sure. Yeah, so just moving on from that one as well. It's a full digitized view of exactly what happened on the manufacturing line. So from process parameters to machine to person that was there to what material, components, placement, X, Y. So that's a massive amount of data. But the power of that is from a design side where you're simulating your product. Even on a semi side, you're running different SKUs on wafers to different types of boards on the PCBA side, SMT. You can replay that backwards, but then feed that back into the design loop and create those closed loop validation of, is it going to work? I just did a new spin-off of a product. Okay, can I use the same line, the same machines? What do I need to change? And just to really close that loop. And that really accelerates things forward. And earlier on I talked about MES controlling quality and reliability. That helps really close that gap early on where it's the most cost efficient, right? You solve the quality reliability issues when it's ready in the line, it's costing you money. If you're trying to solve them when it's out in the field, that's a lot of money, especially medical device.
Yeah. So, Francisco, I'm sure you've got a view on this. You gave a
Yes, I think it's very interesting that Gary and Ryan touch a little bit of this, because I believe that there's typically some confusion about digital twin. It's like a term that's being trained and everyone uses in different perspectives. Okay, so typically digital twins are divided in three main categories. You can have a product digital twin, and this is typically associated with the design of products, PLM systems, and so on. There's a manufacturability digital twins, in which we kind of try to simulate how a given product will be manufactured. And then you have manufacturing and production digital twins.
Yes.
Okay, yeah, so this is the one where, of course, typically MES are more involved.
Mm-hmm.
So what we're talking about here in this case is, with the evolution of MES systems on one side, with the data that is collected, IoT data, or the IoT data platforms, how they are called today, plus the ability to simulate, then you get to the digital twin. So if you like, it's a little bit of the feature of MES, or MES on steroids, which is what I call the digital twins inside manufacturing.
Yes. Yeah. Okay. I remember actually at the conference in Porto, they were talking about digital twin, but from the design side, from all the different, every part of the manufacturing process needed its own digital twin, and then the whole thing was connected together with a digital thread. So it turned into an ecosystem, if you like. Do you have something?
I think it's important to understand what is the difference between a digital twin and a data set. Because we've always had data sets in software. I mean, you have them, we have them, everybody has them. It represents something, represents something about the product or the line or the machine, exactly as you said. But a digital twin goes further in that it has to be a holistic representation. So it's not just containing the data for one application, it's actually containing the data for all applications. Now, you could say that 4 different solutions have 4 different digital twins. They may all have the same data, but they're actually incompatible from each other because they're proprietary. Mm-hmm. So in effect, what is the difference between a digital twin and a proprietary data set? Nothing.
Right.
So why do we have this concept of digital twin? Now, the original thing, if you remember the 3D views of cars as they're being designed, it's in order to communicate a design to manufacturing, or manufacturing to pick up data from the market with which to contextualize and qualify the kind of events that we see throughout the whole life cycle. This kind of implies that there needs to be a standard as to how to be interoperable between digital twins, because design data is in one format, manufacturing in another. So creating the interoperability of digital twins opens up the use of holistic digital twins comprising information from many different sources. That goes into our respective smart software, and that is what then creates exceptional value as compared to simple proprietary data sets.
Right. Okay. Well, that's certainly, and that's obviously us looking into a crystal ball here going forward, because it's not here yet, that's for sure.
It's evolving.
It's evolving. Okay. Yeah. All right. So next question. What are some of these specific use cases where AI is employed in electronics manufacturing processes, and how does it enhance productivity and quality assurance? We'll start with Francisco on that one.
Okay, very well. So, well, first of all, many of the things that are today being discussed within artificial intelligence, machine learning, and so on, have a broad set of applications. And I think we're just scratching the surface right now of what's possible, what's going to be possible. Some of the things are common across all the manufacturing areas. For instance, when you talk about predictive maintenance modules, predictive maintenance is something which can be used in the electronics industry as it can in other areas. And essentially what we're talking about here is the ability to, based on past historical information, derive models that can, upon new data points, predict what's going on with a certain machine in terms of maintenance. So what's the probability of failure? Or what's the remaining useful life of a given equipment? Okay, so that's applicable, obviously, to the manufacturing industry overall and to the electronics as well. Then, of course, once you go deeper into the specific areas of the SMT, you have all sorts of things that can happen, especially on the quality area and quality control. But talking about most of the time is the closed loop aspect. So if you have information from the SPI process, how can you put it back into the next boards that are going through the printer machine? And the IOI, which will give a larger loop, but still the same. ICT tests, the same, right? And so it's not only just very basic rules, but it's also a lot of intelligence, because you have lots of data sets, lots of data points from things that you may not even consider that could influence at the end the quality of a product. And so, that, again, as I said, I think the most important thing is that we're really, really, really just scratching the surface right now.
Yeah, I think you're right. Michael, we'll go to you second.
Oh boy. I mean, within the MES world, I mean, we've been creating data for a long, long time and using that to make decisions. But our customers and your customers, I expect, they expect, okay, can we make more value from that data? And AIs are intelligent. I think that's what the I stands for. And so they're able to do a deeper dive into that data and find attributes which couldn't be discovered in real time, which is where we work. So it is actually elevating that data in terms of value. And maybe Gadi will speak about this because this is your area, but adding value by finding those kinds of things and being able then to produce those as action items for execution in manufacturing. So it's as long as a piece of string. I mean, the predictive maintenance is one, but there are loads of different ones. And the secret is really, how do we structure that passage of the data and elevation of that data to create action from original data from the shop floor?
Right. Okay. Well, I mean, I'm seeing a couple of examples in the inspection world where they're claiming it's AI. I'm not sure if it really is, quite frankly, but one is obviously an automatic setup and programming, so faster programming of machines and things like that and setup. But the other one, which is quite interesting, is they're plotting the results from an operator over maybe a 3-month period and looking at the calls that operator's making and is doing correctly, and then locking that in through into an AI system so that operator can then concentrate on other more troublesome areas, which is quite an interesting development. But there you go.
It's the accumulation of know-how. And we see it, for example, of assisted repair and troubleshooting, where with an AI system, I could go up to some product that's failed, and I would be guided as to how to troubleshoot that. And it's based on the experience of the past. So I think what AI locks in is the use of that experience to discover kind of facts or insights about what is going on in that data and help whoever is trying to do something from achieving what they want. So the knowledge is not necessarily in here. It's actually within the software that gives them help.
A huge database. I mean, it's like ChatGPT. I mean, it's really just a big, huge database at the moment. It's not thinking for itself. Anyway, I don't want to deny Ryan. Do you want to answer the question?
Yeah, sure. And, just preface, I always drop down to an engineering level. For me, that's the fun place to play. For AI, its application right now, today, the accessibility is outlier detection across the entire factory floor. And we talked about from AOI and how it correlates to SPI, to the solder print, mount, all the machine settings. So Michael made a good point. There's knowledge. So the data actually is knowledge. It's kind of cool. But today, there's a tremendous power. You could bring a Python tool set. You can run outlier detection, just unsupervised learning models without having to be a heavy data scientist. So if you have an MES in place, if you have the IoT data collected, and it's hyper contextualized, the barriers to entry drop so quickly, and now first order is right out there. I had a failure, what caused it? Okay, here are all the outliers observed at all prior steps. That will walk the engineer or the process engineer through what is the root cause. And the power of that is I've now given you back 90 to 95% of your life as a process engineer, because you would have to just grind through all that data. But now applying some really great machine learning that's open source today against a good requisite hyperly contextualized data set, you remove the need to do silly things like cleaning of data, identifying your features, this carnage that data scientists spend 90% of their lives doing. With a great MES implementation, IoT backbone, you've now moved the needle forward from a mom and pop single line shop to a global multi-factory distributed system. So that's the value today. And yeah, in the future now, and it's going to come quick, is really, that performance optimization of what should be the settings on the machines. Where was the outlier caused from what setting? That deeper correlation, and then driving it back into design. That's pretty exciting, especially as myself coming back from an original product engineer in semi. I would have loved to have my job down to a one button click, honestly. Yep.
Well, we've had three great answers there. I'm sorry to put you last.
No, it's okay. I will distinguish right now between AI and ML, machine learning. I think that we don't know still, what is the difference between them. We sometimes confuse and say it's AI, but actually it's machine learning. That's one point I want to emphasize. I correlate with you, Michael. I believe that the AI that we are capable to do is the rapid analytics of many inputs, a lot of inputs, to give a results for the engineers. And if you remember engineering in the past, we were doing reverse engineering. We have a defects, going that into the BOM, taking down which machine is putting that. Okay, this machine, this is the head. Okay, let's see. A lot of manual work that actually right now is so rapid that we can. There is an AOI defect. It's come from this nozzle.
Right.
And all of the defects, doesn't matter which defects, come from this nozzle. So I don't know if to call it AI or ML, but it is kind of, I do agree, of the rapid and the accurate.
Yes.
So, and from the future, I see from AI, the Gen AI, you talk about GPT, the possibility to scan multiple documents in a way that wherever technical question you have, you will search into multiple information, database information, and will try to provide an insight for you that you didn't know. Right. That's from that point of view.
Right. Well, that kind of brings me back round to a little argument we had a couple of weeks back, where we were talking about the amount of data that we need to capture. And I was going on the old Cisco mantra, capture everything, and he says he completely disagrees. It has to be contextualized data, highly contextualized data. Otherwise, you're just going to have a whole load of rubbish.
Yeah. If I can add one, it was a fun conversation. It's contextualized data. I think in our brains, our data is very contextualized. Neurons, we connect stuff. We have these relationships. You need to have that in your data. But on the ChatGPT side, I've had some fun testing it. One of my favorite tests is ChatGPT, tell me what Western Electric Rules one is. And it clearly spits out what's on Wikipedia. And by the way, shameless plug, I love donating in Wikipedia. I love open information. Then you ask it Western Electric Rules 2, and it'll tell you Western Electric Rules 1 again. And then it has some preface comment. And then you really just keep testing. Tell me Nelson Electric Rules 3, and it just goes off in the ether. But for me, what was striking about that was the data is there on Wikipedia, contextualized. So somewhere, I'm not sure how the language modeling is working, but when it comes to a scientific linking of elements, you're out in the weeds. At some point, first order for sure, but it's got to get better. But I agree on this massive documentation on the production floor. I think that's a beautiful use of the technology. Start bringing it in, but do not trust it to tie the scientific components together to help drive an engineering decision. Not yet, anyways. Yeah, hopefully they're putting enough money into it and building up big enough data centers to close that loop.
Okay. All right. Thank you for that. So, next question, well, we'll start off with you, Michael, on this one. Why is it important for implementers of factory automation to take a business value-led approach to decision making? Fairly simple question, actually.
Oh
compared
yeah,
to the
very
rest.
simple question. You got to start somewhere with AI, and there are so many different things that you can do. You end up doing AI for AI's sake, like art for art's sake. You have to start with something that's grounded in solving a problem. And in the MES world, we have exactly the same thing. I mean, there's no point in providing 20 different functions if it's only 3 that you need. Mm-hmm. So you got to focus on those 3. So I think it's necessary to have that business-driven, the value-driven, the profit-driven. What is it that actually I need? And then look into, okay, what data do I need to achieve that? Is it a digital twin? Is it a CFX flow of data? How do I contextualize it? That needs to be looked at. And then you go to the AI level, implement this very clever software, and then you see what it's suggesting and see how you would implement that. And then you say, how do I trust that? Would I want that decision to be automated in my operation? Or do I want to use my brain to qualify that? Am I even able to qualify that? Because the AI is so clever that I may not even make the right decision. So you've got a host of decisions to go through. But at the end of it, because it's been led by the business, you've actually solved a problem and made a benefit. That is important because when you go to the next one, you need support from your CEO to make further investments. So it's a cautious step-by-step approach, but generating business value.
Okay. Well, I know you folded AI into that question. I really asked for factory automation, but that's fine. I mean, it was still a very good answer.
It automates the factory.
Absolutely, absolutely. So, Francisco, I'm sure you've got an answer to this.
I think I would like to take a different spin to this because this business value-led type of decisions in our industry is what sometimes leads to specific pilots being implemented in some areas. Without the core elements in place, without the platforms in place. And this is something which is incredibly hard for us because we typically, when we go into deploying a manufacturing execution system, we're not just talking about the single situations that customers might have in mind at a certain point in time, right? So we really need to put the basic framework, the basic platforms in place so that we don't fall into what is called the pilot purgatory. I'm not sure if you probably heard about this already, but many of these pilots, they don't scale. The conditions change. They're not applicable if something is different. And so this business value approach needs to be done after you have the basic things in place so that you can then start to apply business value decisions, continuous improvement on top of that. But it's really a difficult conversation because it's a little bit like, how do you take a business value decision when you are to implement an ERP? Right. You basically have to have the ERP there first. Yes. And only then come to do the specific business value decisions. So that's the way I see the MES, the automation frameworks, the data platforms, exactly the same way.
Yeah, I think you're right. I think, Gary, I mean, when anybody's making a factory automation decision, it's obviously going to require investment of some sort. So you've got to make the business case to the C-suite management, to get buy-in from them, before you do it. Otherwise, why do it?
Yeah, from my point of view, I think that I'm again correlate with Michael, asking the right question. What is actually the pain point? What is your pain point? And according to the pain point you're trying to drive, what's the added value proposition? And according to that, driving the automation for the data to apply the right tool to implement that. Automation eventually should eliminate, from my point of view, human errors. In data point that you actually take different KPIs numbers and then you take different wrong decision because the data was wrong. Mm-hmm. So automation is trying to eliminate that phase and take the right decision from that point of view. But definitely not everywhere, but in the right place that there is a pain point. Otherwise, there's no added value for that.
Yeah, that's true. Do you have anything to add to that? Yeah?
Yeah, sure. Not too much. I'll Yeah, all really strong, great points. The business value, it's interesting. So MES can be looked at fairly complex from the customer. Trying to explain what you can deliver. You can overwhelm that. So as you mentioned, that key challenge, the pain points, you go after that. You define the business value very clearly with that, and that's great because you get the buy-in. Because if you don't get that strong enough buy-in, I mean, you're doing a cultural change when you go on at a data-centric. And a large part of the electronics market is not really ready for that change. There's a number of key companies that are, and you see there's global behemoths. But that's because they've done that data-centric approach in many layers. So that's key for the buy-in. Just key challenges. But I always like to open up the value too. I like to let the engineering down below. You get buy-in from the decision points. Put the money there, make sure you're ready for the change. But the other part is to let the operational layer too know that what the value is going to be to them. So you get this buy-in from the top and the bottom, and it's just this perfect decision sandwich. You come in, we're going to make your life so easy on the bottom, right? You love to be engineers, you love to be technicians. We're just going to empower you. You're going to have information and data at your fingertips. It's not displacing your job. If anything, it accelerates what you're able to do. It'll give you time back to put more time. And when you start to talk to that layer, you just start to see the nods. Oh, I can actually take a break, for more than 20 minutes a day, that kind of thing. But, so for me, the business value kind of sits at the top, but there's also this business value that sits within the operational side. And if you capture both of that, you're guaranteed success in your deployment.
Yeah, no, I think you're absolutely right. But I don't know if any of you watched the debate between Rishi Sunak and Elon Musk a couple of weeks ago at the AI conference. But that was kind of interesting because Sunak made the same comment that AI is going to augment your job. It's going to support your job. It's not going to replace the jobs. And of course, Musk replied, "It's going to replace the jobs." But he's just got to be different, isn't he? My final question, and we're running out of time, guys, so we're going to have to make this relatively short. As governments try to regulate ethical development of AI, would the industry benefit from a benchmarking system to chart their digital transformation and manufacturing capabilities? And there's a couple of proposals out there at the moment. There's the Siri one, which comes originally from Singapore government, which the chap from the World Economic Forum presented at your conference. There's also one that's been announced within the last couple of weeks from SEMI, which is more of an industry level one, but same sort of idea. So let's get your feedback on that. I'll just go along the line. You start first.
Okay. Yeah, for me, I actually struggle to really understand how they can actually press that onto industry at this point. I mean, there's still just so much, we're still having to get ourselves baseline on IoT, great data collection, that kind of thing, before you can really start to grind that kind of information out through AI, to an industry body that now makes decisions almost in a way of where your product's going to be built, who we're going to use. So me, it's a little ephemeral still, but it is a great thing that they're thinking about it, getting ahead of it. So I kind of, to be honest, I kind of struggle. I mean, I'm waiting for it to be a little bit more deterministic, contextualized. Thank you.
Actually, I'm the same with you. I think that I mentioned in the beginning, we are using more machine learning than the AI. So regulation right now, talking about regulation, is premature a little bit.
Okay.
Not on the regulations part, but on the benchmark part. So talking about Siri, which is the one that's a Smart Industry Readiness Index. It's a difficult one to say. Yeah. And it's really cool in a number of ways and very quickly. First, because it covers technology, it covers processes, it covers organization, it covers the entire spectrum involved there. Second, because it has a lot of segment-specific things built in. And there's a lot of data already for allowing benchmarking. And just two things which is really cool for the electronics industry is that the electronics industry is currently, according to the CRX index, the one with the second highest maturity from the 14 different segments that have been evaluated, semiconductor, of course, being the highest one. But also is the number one in terms of variability.
Sorry?
In terms of variability, in terms of variance, which means that, yes, you have very advanced companies that are doing a lot of things that have a very high maturity, but then you have also the opposite. So it's a really interesting report to look into, and Siri is doing a great job there.
Yeah, I don't think it's a set of actual rules, is it? I mean, it's more a measure of your measuring your preparedness on the journey towards factory automation. And yes, it gives you a benchmark score, but it also sets you goals.
Exactly. So you can not only assess where you are, but you assess it versus where you want to be,
Right.
where it makes sense for you to be.
Mhm.
Okay, because it does not make sense for all the industries to go into a specific level. Right?
Okay.
So again, very interesting index to look into.
Right. Last word to you, Michael. Make it short.
So, do we want the man coming into manufacturing? Probably not. I think the generative AI definitely needs to be managed very, very carefully, and that's what Elon Musk was talking about. Within manufacturing, I think the benchmarking is very important, and it's not to protect us against AI. It's actually there to see where are we in our journey toward taking full advantage of the values of AI. Because a lot of people don't really understand, okay, I've got this data, what can I do with it? Maybe this, and then they don't see the other 6 or 8 values that they could have generated. So by having a benchmark that shows their preparedness, their thoughts, their intents, what problems they would solve with it, I think it acts as a motivation for people to become smart in their factories, to make the best use of AI, to make sure that it's done properly, of course. That because it is the old garbage in, garbage out. If you don't contextualize the information, as you mentioned earlier, you are going to end up with a lake full of garbage. So it has to be done properly and in the right way. So I would welcome those kinds of things.
Great. Well, we've had some superb answers today. Thank you very much, gentlemen. It's been a great debate. So thank you to Michael Ford from Aegis, to Francisco Alamada from Critical Manufacturing, Getty Make from Arch Systems, and Ryan Gamble from Interratio. Thank you, gentlemen, and thank you to our audience today for watching. We will be coming back after the break with our next panel discussion on AOI inspection and X-ray in the semiconductor world.